Hello everyone. So as I have said last time, we do not finish with two variable case, but we will continue more to the n variables. Okay, this will be the general case and will be a chance for you to review the past concepts that we have talked about. Okay, so this is the first part, and second part will be in the next video. So this is the outline. So the first three topics, okay, the first three topics will be the topics that we will discuss in this video, which is lecture 19. Okay, we talk about joint PDF, joint CDF, marginal distribution, independent random variables. You see, the topics are the same. Okay, so the intuition carry forward, but we are going to look it in the general case. Okay, and in the next session, we are going to talk about the conditional distribution. Okay, and the histogram. So let's start. So what is the joint CDF? Joint CDF of the n random variables is the function f such that if the argument, okay, because it is an n variable case, so the argument will be x1 to xn. And what does it mean? It means that x1 less than or equal to x1 until big xn is less than or equal to xn. This is very similar to the two variable case, right? So what's the joint discrete distribution? It's the same. The convention is the same, okay? And this one is this probability. Next. So the continuous PDF, what does it mean continuous? That means we have the F here, okay? Where if we have to find the C, but C is not a subset of real number, okay? Let's recall the first lesson we talked about subset of real number. And the last few lessons, we have talked about the subset of R2, okay? But now, it is the subset of Rn, okay? That is, if this one is the element of the big C, okay? This, not the department store, okay? It's the big capital letter C. So, this one is the indication with the C here, okay? So, from the CDF to PDF, so if we have the PDF, let's say that we have n variables, right? We have n variables. So let's say in the first lesson, we talk about one variable case, which is we take derivative one time. For the last few lessons, we talk about two variable case. We say that take derivative two times. But now we take the derivative of n time. Let's say symbol here. This means take variable n time with respect to x1, x2 until xn. So let's see the first example. Given the joint probability distribution of x as follows, okay? Find normalizing constant C. If we want to find normalizing constant C, we have to integrate what? Because we have to convert from PDF, okay? PDF to, let's say, similar to CDF. Okay? So, we have to take the integration. This is tedious, but it's not difficult, okay? So after a few integration, you see the pattern and we get this equation. So C is equal to 2 times n factorial. The concept is the same, you see. For the second example, given the joint PF or PDF of this one, okay, we have how many variables here? M plus 1, okay, because we are counting P also. So we have this one for the S with under this condition. We want to find x1 plus x2 is equal to 1 given m is equal to 4. So what we wish we knew? We wish we know P, right? Similar to what have we discussed. So because the problem say that m is equal to 4 and x1 plus x2 equal to 1. So we plug in and we rearrange into this expression. Okay, and then because we knew that x3 and x4 is in 0 to 1, so we have two layers here that we need to consider, because we have this one, right, with under this condition, but we have to find for all possible combination of x3, x4 and all possible combination of p. This is the mixed distribution. Remember, we have talked about the mixed distribution already. So we could take either the sum or the integral first. That's fine. So in this example, we have to sum because x3 and x4 is discrete. There are 4 combinations. Okay, because x3 and x4 is in the set of 0 or 1. So summing over x3 and x4, we get this expression. And then we have the p, right? P is what? Continuous. This one become continuous now, continuous in p. So we have to take the integration. Integration between 0 and 1, and this easy, okay? Is equal to 1 over 6. Then note that because we find what? We find only one kind of distribution, okay? Because this one, we implicitly assume that we take, let's say, either 1, 0 or 0, 1, but we take just one combination. But there are two combinations. Think of it as the binomial distribution, okay? So this one is an umbrella for any combination, but we have to multiply by 2 choose 1, okay? 2 choose 1. And there are two vectors here such that x1 plus x2 is equal to 1. So the probability of x1 plus x2 is equal to 1/3. Okay. Then we talk about marginal distribution. Marginal distribution, it is a way to flatten, right? Let's say we have the function of x1 up until xn, but we want only the function of x1. We want only the function of x1. So the way to eliminate x2 up until xn is to take the integration for n minus 1 times. Okay, so for example, and this one doesn't hold only for one variable, but for any pair of variable. Let's see this example. If f is the joint distribution of 4 random variables, then the marginal bivariate, even bivariate, we can use this formula. Okay, because the logic is the same. So F24, what does it mean? We have to eliminate x1 and x3, right? x1, x3. So the way to eliminate this, because we have this one as a function of x1, x2, x3, and x4. So we have to eliminate this by integrating with respect to the x1. And then we integrate another layer to get rid of x3 by taking this layer of integration. Okay. Next, from CDF to marginal. Consider the joint distribution for which CDF is like this. So we have to find the marginal CDF. So remember, because this one is, because the CDF, what does CDF mean? The probability of big x1 less than or equal to small x1, big x2 less than or equal to small x2, and then big xn equal to small xn. So the way to find out this because we have to get rid of what? We have to get rid of h2 up until xn. The way to eliminate this is to take the limit, right? The limit x2 to infinity, then this is not a function of x2 anymore. And then x3 up until xn go to infinity. And this one will not be the function of x2 up until xn, but it is the function of only, let's say, of only x1. It is the function of only x1. So this is the formula here. The same logic as in the previous lesson. So as I've said that this lesson will be like a review, a mini review, okay? But we will have the review later after we have finished the whole chapter, okay? And we are going to go to some practice problems also. And then this is the same, okay? If we have to get rid of x1, x3, we x1, x3 to infinity, and this one is not the function of x1 and x3 anymore, okay? So next, independent random variable. The concept is the same, okay? So x1 in this one, that means we can multiply these blocks together. And the special case is the big F, okay? It's the same logic. And then if big F is true, small f is true. It is very similar, okay? Very similar to last problem, okay? That is, we can decompose, we can reconstruct, okay? Let's say reconstruct from the marginal to PDF. Because what? Because from PDF, we can construct two marginal, right? We can construct two marginal. However, from the marginal, we cannot construct to the PDF except one special case, except the case of independence. If it is independent, so you can go the other way around, okay? So the third example, suppose the lifetime of each light bulb is distributed according to the following PDF, given that each light bulb lifetime is independent, okay? So the problem must say that it's independent so that we can reconstruct from the what? The marginal, okay? The marginal to PDF, which is the joint distribution. So finding the joint distribution, it is multiplying, is simple, okay? And then we find the probability of the sum of I equal to 1 up to n of xi is less than a, okay? Less than a. So we cannot find the closed form formula, unfortunately, because we have the ended, and this is a bit difficult to do, okay? But we will revisit this problem again in the next two lessons when we talk about the concept of convolution. So stay tuned. But for now, let's keep it simple because we don't know any formula, okay? So we cannot find the closed form solution. The best way that you can do is integrate PDF, okay? Integrate the PDF under the C, okay? And the C is the area, okay? C is the area. This the C is the vector x such that sum of xi less than the a. And find the probability of x1 less than x2 up to xn. So this one, we can find the closed form solution because they are identical. This one are identical. So the probability that it is just what? x1 less than x2 up to xn, it is just what do we call the permutation. This is the problem of the permutation. So when this is the problem of permutation, if everything is identical, we can use the symmetry. Okay, the symmetry is such that it is order that x1 come first and x2 until xn. It is 1 over n factorial. Because given n seed, we have to place x1 and x2. We have n factorial permutation, but only one permutation is allowed. Okay. So that is the end of the first part. And we are going to see you in the second part in the next video. So good luck and see you next time.